it's a bit more preliminary than we wanted, but this is a new project. This is the second time I ever present. And let's go. So what we are doing. So let's start with somehow the theoretical motivation, and at some point I will give some more applied motivation. So two-sided limited commitment models with long-run contracts are one of the most popular frameworks to study risk sharing in many environments. And then I will talk about now a little bit three examples. Marriage. This is going to be kind of the example which we are going to put together. Partnerships, which is kind of, I think, about law firms, consulting firms, which are kind of different partners work together. Economics unions. I didn't put the fourth one because I didn't want to enter a kind of juicy issue today, but countries can split up, and that's an issue which you may have to consider, and this is a long-term contract. And what is specific of most of the literature, not all I will talk about, that in the theoretical papers, they don't allow for two things in this kind of case. There are very often no separations along the optimal path. Second, there is no asset accumulation by the partnership. I call the partnership then this group. So there is no assets which are accumulated over time. Of course, for empirical applications, these features are relevant. In couples, there is divorce. There is someone may leave the European Union, someone may leave a country around here, or whatever. And partners can leave a partnership, and also, in all these cases, there are common assets, and these common assets are accumulated, and of course, are going to affect the risk sharing and the separations, how we think about assets accumulated. And that's going to be what we are going to do in this paper. So what are kind of the issues which can come up with efficient separations? And okay, what is the first thing in the title? Asset division rules. So what do I mean when there is divorce? In different countries, in different states, there are different ways to divide the assets of the two parties. And these rules are going to be important for both risk sharing and then for separations and for giving incentives for asset accumulations. So this is kind of one easy intuition, which is going to hold until the half of the presentation, I think, that assets, if less assets are provided for those who would like to separate, who would like to leave this partnership, the less assets are provided, this is the better for risk sharing, because you reduce the incentives to leave the partnership. But there is another argument which can always say that why do we care about risk sharing? Because agents of concave utility means risk aversion, but it means, more importantly, consumption smoothing. Agents like to have consumption smoothing. So providing assets upon default, divorce, or any of these separations might be useful because they are going to give consumption smoothing across the separations, which is, of course, not present in any model which has no efficient separations. If there are no efficient separations, this consideration would never come up. So that's kind of a specific one coming out from here.
But this division group may also affect the way you accumulate assets.
Yeah, that's kind of, it's going to be somewhere here, I think, or the next one. Yes, this is going to be the kind of the questions we talk about. So what we are going to do now, this is kind of where we thought about, though this is kind of an interesting issue, but then we were stuck. We started reading and we didn't find any paper to give real characterization of this, trying to understand the theory. So what we are doing today, we are going to give you some characterization results in this environment, kind of build up slowly more and more complicated ones, but the most complicated version is going to be much less complicated than anything we see today. So that's going to be, but we are going to do step by step. So what we think, we are the first paper to study formally these three things together. Two-sided lack of commitment, efficient separations, and asset accumulation. We follow up our previous paper, which had added asset accumulation, but we added efficient separations through shocks to match value. It's actually, funny enough, Nazi and the organizers made a nice job because there are many similarities in one abstract way with the paper of Rachel, because we will talk a lot about match value. And match value triggering moving, not from houses, meaning moving away from your partner, but it's still going to be very similar. And we are going to study asset division rules upon default, which we didn't study there. We use only one. So what questions we are going to answer? How efficient separation asset division rules affect risk sharing? So we are going to think about how risk sharing is changing when we allow for separations, and we study different asset division rules. Second, exactly as Kiku said, how asset accumulation incentives change with these new features. Whether couples would like to accumulate more or less, what does it depend on? These are kind of the questions we try to answer. Some results. I don't do that. So let's do the results after, because I think maybe we just lose time and then I may come back to this. Okay? So what is the literature? So in terms of lack of commitment models with or without storage, I just put, there are many papers, but let me put somehow kind of historical. There is Kocher-Lakota, two-sided lack of commitment, Kruger and Ulich, one-sided lack of commitment but with storage, and us with two-sided lack of commitment and storage. So this is like the theory. There are limited commitment models of couples, and there are many. I put somehow one of kind of an earlier one and the very recent models, very well cited, Mazzocco and Vuena. They feature similar characteristics in our model, but again, what is missing is somehow kind of a structured thing weighing about the theory of this. And what we really like, we just, Chiappori and Mazzocco has a survey of all the household literature. It's a very recent survey. And they claim that the model which I'm going to present to you, which should be the workhorse model of household allocation. This is the model which I said. Households are going to have limited commitment. They are going to have asset accumulation, and there are efficient separations, probably there is divorce. But they provide some characterization here for partial versions of this model, but not kind of the way we do it. So that seems to mean that this is an important model. That's kind of our interpretation at least. So let's see. So the model is going to be simple. And before going into this, let me say what was the objective. The objective here was not to make the quantitatively relevant model yet, because today we are going to talk about theory, rather to make the simplest model when we can make the case and highlight some of the features and not worrying about some of the very relevant empirical features, but which are going to complicate the analysis but not changing the qualitative features. So what does it mean? We are going to build on Kocher-Lakota, which we built up in another paper, and what is going to be the main features? There are going to be two infinitely lived risk-averse accent-identical agents. So there is not going to be a difference between men and women. There is going to be accent-identical, and it's going to give us a lot of symmetry, which simplifies the algebra. They are risk-averse, and again. So what type of shocks they are going to face? Again, these two bullet points is Kocher-Lakota. They will face an income shock. Why? It's going to have discrete support. It's going to be IID, and perfectly negatively correlated across the two agents. What does it mean? There is no aggregate risk in the sense that aggregate endowment is always constant. Why we do this? Because this saves us one state variable. Now we just have to think about what is the distribution of income. And then it gives full symmetry. So that's, again, you can extend it. All the qualitative results are going to be true together with some other movements, because there are going to be aggregate movements. So this is Kocher-Lakota. What do we add in this paper before? We add storage. And we are going to add these other things in the current paper. So what is storage? There is going to be storage and saving technology for the couple, which is going to be a technology which is going to be typically inferior to the time discounting. So the technology is worse than how agents are discounting the future. Why we do this? Because in this sense, we know that if this storage technology is going to be implemented, it's just because of the limited commitment and somehow the unlimited risk sharing because of limited commitment, because at the first best, you would never use this technology because it's inferior. In the first best, you would never use storage because you can assume that this is a strict inequality for today. I will not use the case was very weak. So this is only going to be used because of the limited commitment friction in this model. What we are going to assume, this is somehow, it's an important one, and in the literature, it's somehow what we understood is not very clearly spelled out often, that storage is decided efficiently by the couple. So somehow we think about there is a couple social planner, and that's going to decide always efficiently for the couple's point of view how much they want to save. Okay? There is not going to be any borrowing. So this is somehow a joint decision. This is in the previous paper. So what do we add? We add two things. One is in this slide, and another one is in another slide. So agents are going to face love shocks. I was thinking about it today, and I think love is a bad name. But we are not the first one to call it. I don't want to go too much to PG category, but it's more like pleasure, what we have in mind, because love is somehow has some altruistic component. So what do we mean? That that both partners are going to experience some match quality, which is going to be alpha. As well. but hate, okay, let me just give you some, why love and hate is not good. Because when love and hate, then when you love somebody, you want her to be happy, no? And you hate somebody, you want him to be unhappy. But what we care is that I am happy in this model, and there is no altruistic part or negative altruism. So that's why it's not necessarily love, it's pleasure. So you take some pleasure to being in a match, and this is going to be denoted by alpha. There is going to be another big simplifying assumption for the same reason, for symmetry and for tractability of one state variable. This is going to be perfectly negatively correlated with the mean 0, and we are going to assume normality. You can do many things. Normality is useful because this is unbounded, so you can really love so much, as much as until infinity, and hate so much to infinity. That's
negatively correlated over time, over agents.
Over across the two agents. So if you love somebody, if you love your partner, she hates you. This is again. It's necessary just to reduce the state space and get something analytical. And then there will be. Okay, just a second. Phi. Just let me. If I said it, phi is the density. And capital phi is the cumulative distribution function for notation of this love shock. Matthias?
So given the motivation, I expected that you would have some common mean that in sometimes really the marriage makes less sense. So now there's basically no notion of that, right? So in each point in time in terms of what I can expect or the future economic benefits, it's always the same, right? So times
so we can also do that you both, that it is moving together. So let me say, why do we do this? And we didn't have a better idea. So kind of maybe partially because of history dependence of the project, we like to think about who should get more assets. You can imagine many different phases in the next slide. So actually I can talk about what happens at divorce, and let me just talk about it here, okay?
Well, why can't you have perfectly positive correlation?
Because then it's perfectly positive. There is always mutual agreement that you want to divorce, and we can do that, but it kind of makes less interesting to. Let me talk about it here. We can do that, and we probably will do that as well. But I think it's not that obvious that you want to have that perfect correlation, but the negative correlation is obviously a strong assumption. I agree. with that. So let's see what happens upon divorce, and then I will come back to this discussion here. Okay?
When you marry, you don't love the other. Alpha is 0.
No, of course you love. You always love or not.
Why the guy that hates you will marry with you?
I mean, okay. So that is not it's not a choice. It's not a choice here. But second, it could be it's not a choice here. You are in a relationship for his sharing and for pleasure, and then pleasure is not symmetric here. That's what I say. And the sharing is always one reason. If the sigma 0 is going to be one special, sigma is equal 0, then you are all in the marriage for his sharing and not for any other reason. So that's kind of one way to think.
This assumption makes the risk sharing much more interesting.
Exactly. Yeah.
You have to put up with something.
Yeah, no, I think let's just talk about divorce, and then I will explain what we do and what else we could do, and then this is what we have today. So what happens about divorce? Agents can leave the relationship at any time if they find it optimal. So that's going to be kind of self-enforcing, and there is going to be, because of the love shock, there are going to be separations which are going to happen on the equilibrium path as opposed to the typical Coachella quota type of models. If they divorce, they are going to live in autarky permanently, where they can use the storage technology. We can assume that they can remarry with some random probability. That wouldn't change anything qualitatively. It's just going to be, outside ocean is going to be a bit more attractive. So it's quantitatively important, but not qualitatively. So upon divorce, one important issue is what happens with the accumulated assets. So what we are going to do, and that's why it was important that we can define who wants to get divorced and who hates and who loves, this comes here. So what we are going to think is that gamma share of the accumulated assets is going to the guy who files for divorce. This is something which we assume is less than 1/2. There are many countries there is a punishment for those who are kind of the unfaithful one in the marriage. They are the ones who are going to be punished by the judge. So there is some evidence in that in some US states and in some countries. So that means gamma is 0, less than 1/2, something like that. And 1 minus gamma is going to the other party. So sometimes this is important for two reasons. Whenever in this model you contemplate about, do I want to stay or do I want to leave? Then you are going to say, okay, if I leave, I'm going to be the one who files for divorce, and I will get only gamma proportion, which is less than 1/2. That's the way, this is the way we think about it. You have to think, and that's, 1/2 is one nice benchmark. I will talk about it every now and then, but it doesn't have to be 1/2. The extreme case when it is 0. And you will see when 0 is very nice for efficiency, as you think, but not all the way. Again, as you will see, after half of the talk we see is not always okay to that one.
But in this case, both of them file exactly at the same time?
Exactly. No. When there is divorce, you are right. You are one step forward. When you have divorce, we assume that the one who really hates, that's going to get the bad deal. Because we assume that the one who hates, that's the one who files for divorce. For now, that's.
And over time, that alpha shock is IID.
Is IID. IID is again for just to be able to prove. Persistent with positive autocorrelation would not make any difference qualitatively, but the proofs wouldn't work. Albert?
I think that most countries nowadays, the legal value for gamma is 1/2.
Yes, it's true. But you see, there are efficiency arguments why it should be less.
If we observe that it's not 1/2, it's because obviously this is something you bargain about. But anyway,
No.
I think gamma close to 0 is not even.
No, but gamma equals 0 is important from a normative point of view. This looks like an efficient thing to do. I agree that's why, and it's not always 1/2. So, and then I think you said one interesting point though, which I would say later, that gamma is exogenous. I think one way which we are thinking about doing it is gamma is somehow evolving. It depends on your kind of temporary Pareto weight or bargaining weight. So that is something which we could consider. That is not nested in here yet, because it's exogenous. Okay, so let's do preliminary characterization. This is going to be very similar to, in some sense, to Rachel, who said if you're really fed up with your house, you just move.
Well, I thought you were going to say about the reason you started thinking of it.
No comment. So what is this characterization? There are going to be thresholds. And these thresholds, so if you think about the proof, which I will not give you any formal proof, this is going to be somehow guess and verify. I will assume that there is this threshold, then given this threshold I do a formulation, and then you can see how this threshold determines. So let's just now believe me that there is this threshold. How these thresholds are going to look is that this alpha star, I will say it's just a positive number, but I'm going to say that exists this alpha star, which depends on the accumulated assets of the couple and the current income shock of partner 1.
But sorry, but preferences. So you have a utility functional over consumption that is concave.
Yes, I said risk averse.
And the epsilon that is shocks.
Alpha.
You're at the alpha.
They are just additive utility shocks. Yes.
And when I'm separated, I'm flatlining at 0 with that. So
that I didn't say. You are right. There is no love left.
There's no, and I can never go back to. So then I'm
for now, you cannot go back. That's kind of that's not an important assumption. That it's.
But I can still say so. I'm in a Bewley.
Yeah, exactly. I will show the formula is coming next slide, by the way, of all this or two.
So it is not transferable, but is it possible to transfer some of these alpha to keep the other person?
Yes, and you will see in some sense, yes, you will see that is coming also. So I follow the Kiku strategy, promise everything now, and then let's see whether I deliver. So what is coming? Both of them are coming soon.
So what can I do with the asset? Can I just steal the asset in the period before divorce?
No. Okay, this is somehow, now we are in a world of really nice kind of legal structure that the couple's assets are safe. No, but it's a common account and you cannot steal it. This is another interesting thing which we may study.
I mean, in terms of eating it up. I mean, I tell you, like, forget about the old contract that we're having. I'm now threatening, if you're not filing, I'm going to eat it up all today, have a big feast.
Yeah, I mean, that type of, we don't allow for that. And this is interesting. And this may be more interesting if you have persistent shocks, because I had these shocks today, I love you, but tomorrow I can hate you. So it's not, there is not this case that all things are getting worse, I start to eat it up. In a persistent shock is more important, and probably we would see that. And then that's a good point. I will write it down later, I hope. So that would change a little bit the story. You are right.
But the way income is shared within the couple is exogenous.
Income, yes. Consumption, not at all. Income is exogenous. Consumption is going to be endogenously shared. So that's why income is exogenous, but consumption is coming again. Next slide, I will define the problem formally.
With a good alpha, I can offer to the other more more in order to...
Exactly. That's exactly what's going to happen. This is exactly what's going to happen. So that's good. So these thresholds are going to be somehow very simple. If it's about an absolute value of alpha, if alpha is very negative, then agent 1 is just going to file for divorce whatever. That's the case. And this is what is threshold is going to depend how much assets we have, because this is kind of suppose that gamma is equal 0 or low or whatever. This is something which you have keep some part or not when you divorce. It's going to depend on alpha, B, and it's going to depend, of course, your current income. What is how tough you are.
So I'm surprised there's no cross-state variable in that function alpha star. The cross-state variable that
there is a co-state variable inside the contract, but not at the limit. Not at the limit. That's the point. Exactly. So you will see. If not, ask me back because I will show you the equations and we can talk about it. But there is no. Okay. I said it. So there is a symmetric threshold, which is going to be when your partner is going to filing for divorce. So there is alpha star, again, function of B, and y minus capital Y minus lowercase y, which is going to be the threshold for the other guy to file. So whenever when you love somebody a lot, this is the weird part, then your partner is going to file for you divorce because of the symmetry property. Okay. So intuition. So what happens? For negative life shocks, agents need to be compensated by current consumption and future utilities. So I'm really having a negative life shock. So how can I stay in this marriage? The way to stay in the marriage, I need to get more consumption, and I need to be promised in the future I'm going to be treated very well. Then I may stay. No, that's the idea. But then there is some limit to that. Future utility, they cannot promise you too much because at that point they want to leave. If they cannot, that there is no credible promises over a limit because it's going to violate their participation constraint. Current consumption, you cannot promise too much because it's going to reduce the other partner's consumption and there is a feasibility constraint. So at some point, if the life shock is negative enough, you have to be there is no way to compensate and you will file for divorce. The other way to see it, and this is going to be seen after the equations, for high enough alpha, you cannot satisfy both participation constraint. That's the key. You cannot satisfy both participation constraint, and that's going to determine alpha star. Okay? I already said it. No, this one. No. The capacity to compensate agents for adverse life shocks depends on the aggregate assets. So more assets, you can compensate a bit more because there are more cookies on the table. So finally, the formulation. So I'm going to write it. This is going to be a long equation. Actually, this is not but this slide. So, and I don't know how much you see, actually. That is, I didn't think. But let me just, it's not that difficult, by the way, what's going on, just to see by segments. So there is going to be, this is the utility of partner 1, who has income y and alpha shock 1. And B is the aggregate assets. This is the individual state. And U is how much utility currently is offered to the partner. And we assume that at this point, let me finish this one. At this point, there is not going to be any, assuming that in this point there is no divorce. The divorce, we are in the state when there is no divorce. So what happens contemporaneously? What decisions are making? We are offering state contingent continuation utilities. For whatever is the state tomorrow in terms of income and love, we will tell you how much utility you are going to give to your partner. You are going to decide how much to accumulate assets and how much consumption. You give one consumption determines the other one. What is contemporaneous utility? As I explained to Matthias, concave function of consumption plus alpha. The life shock is just linear. And then what are the possible states tomorrow? You discount with beta. There is a probability of realizations of y. And then the integral with respect to the life shocks. There is going to be within the thresholds, the marriage stays together. It's a recursive formation. This is just the future updated value function, okay? There is nothing fancy there. The promised utility is coming here. There are two other cases. With some probability, the life shock is going to be so bad that there is going to be divorce triggered by agent 1. So then agent 1 is going to, this is the probability of that event. By normality and unboundedness, it's always like this is alpha stars. It's always a positive number. This is going to be the utility. He's in autarky. He receives gamma proportional on assets. He restarts. The symmetric event. Now, the life shock is so bad for the other partner. This is the probability of that event that she's going to file divorce. At that point, our guy number 1 is going to go in autarky. He was left. but he's going to receive 1 minus gamma of the assets. Okay, this could be both 1/2, it could be 0, 1. These are the cases I will talk about more. Matthias. This is we are looking for a constraint efficient allocation. Constraint efficient allocation there is, and that is, I don't know, so looking for what is the best allocation you can provide given this set of constraints, and given that you may want to allow for efficient separations. So it's constraint efficiency. I mean, what is the equilibrium? And agents can always deviate to autarky. They can always file for divorce. Okay? That's the equilibrium concept. You will see it.
So it's a contingent plan of consumption while in marriage?
Exactly. It's a long-term contract.
The participant, or well, not. I have to.
You see?
To respect that people will go into autarky if they want.
Exactly. This is coming here. Participation constraints.
And maximizing what? Can I think about?
You maximize weighted average of the utilities of the two partners, and the weights are going to be kind of endogenous. Not kind of. They are endogenous. Let me just formulate it differently. So there is going to, okay, if you are not familiar with this literature, there are 2 ways to explain it. I didn't use the Marset-Monimond formulation. I used the promiscuity formulation. So what is the best way to give utility U to your partner? What is the most efficient way in terms of maximizing your utility to provide a lifetime utility U to your partner? What does it mean? That you are working on a constraint Pareto frontier. This is a Pareto problem. Maximizing utility 1, subject to utility 2, subject to constraints. Okay? So this is a constraint Pareto frontier. In this sense, you can think about equilibrium, but I would look at for a constraint Pareto frontier problem.
Right? So
exactly.
Still in the
Exactly.
beginning of time, it's still indexed by
Exactly. There is a U0. Sorry. If that was your question, sorry, I answered too long. There is a U0 which is initialized somehow outside of our model for now. No. What is important that if you have only income, you never want to separate because there are 2 agents facing risk. There is always some gains on the table, some surplus to share, and then you need some other shocks which makes efficient separations happening.
Instead a discrete love shock and a continuous income shock?
No problem. It is just easier with thresholds. With discrete shocks, there are sometimes this threshold doesn't exist. It's just much easier with the continuous, but there is no qualitative or theoretical reason otherwise, just simplicity or tractability. I'm running out. Did I answer?
No, I can talk about it later.
So promise keeping constraint is just I have to deliver what I have to deliver. So the lifetime utility U. Contemporaneous utility, he consumes the rest, or she. There's a love shock. Continuation is the same. Marriage stays together. I have to deliver W, what I promised. If there is divorce, completely the symmetric idea happens. So the same. Participation constraints. But I have to make sure that whatever I promise is better than what my partner can get by filing for divorce. This is one. In every part, I have to make sure that she doesn't want to divorce. I have to make sure that tomorrow I will not be in a situation I want to divorce. But this happens as opposed to the general model only in the range of alphas when the marriage is supposed to stick together. So what is the definition of the outside option is just as Matthias told me, is just going to be the agents are borrow and save and leave alone. There is no alpha anywhere. It just depends on their asset holdings and their income. It's just a simple self-insurance problem with a fixed return, which is a storage return. The definition of the threshold, I wanted to talk more about it, and I may not have time. It's somehow tricky, but somehow also beautiful, I would say. So what the heck is this? So what happens is that now, imagine that I keep my partner at her outside option. I cannot give her less because then she would file for divorce. Then this is the current state variable, and I make the love shock worse and worse. My own utility is going to decrease because these are not changing. These are all constant. As I hate the partner more and more, my utility has to decline and decline. At some point, it's going to decline as much that I'm going to be worse off than myself filing for divorce. At that point, this marriage has no future because we cannot satisfy both of the participation constraints simultaneously. This determines alpha star because it's monotone. This doesn't depend on alpha. You can prove existence very simply. So it's monotone decreasing, and because concavity, you need concavity for that, but The value function is concave because the utility function is concave. You don't need anything more.
And for now, the gamma is exogenous, right?
Yeah, gamma is it's going to be exogenous in the whole paper. We do comparative statics more. I mean, I'm actually going slowly, so we are going to do comparative statics in intuition at best.
Can you do it again, because it's very important?
This is very important for me as well. So, so this is the value function of partner 1, okay? Assume that the partner 1 is already putting the, let's call the wife, just to be politically incorrect, or I'm not correct because I'm the bad guy, the husband. So let's put the wife into the worst state, her outside option. You cannot do worse with her because then she files for divorce. This is states which we don't change. So let's take this situation. If alpha is getting more and more negative, what happens? I'm going to be worse and worse off. This part the same, I'm getting worse and worse off because I get this negative utility from the hate. At some point I'm going to be that worse off that I'm going to be worse off than filing myself for divorce. At that point, you cannot satisfy both participation constraints because I do already the worst to my partner, and even if I give her the worst, I still worse off staying in the marriage than divorcing because of this alpha is so high. This determines the threshold. I cannot do one more time, sorry. So, I know. I will explain you in the bus, on the bus. So, there are special cases which are going to be very nice and easy, and the last one is going to be complicated. So let's do the special cases. No storage, but there are efficient separations. So this is Kocher-Lakota efficient separation, which I didn't see. But this is kind of what happens. There is going to be, within the divorce thresholds, the characterization is very similar to the benchmark model. Why? Because that's the way it is, and I will not have time to prove. Consumption is going to be as smooth as possible given participation constraints. Consumption responds only to large swings in income and love shocks because otherwise you don't have to respond. You want to smooth consumption as much as possible. History is erased when consumption changes. These are typical properties of these models. So this is, in this range, is just the same model as the typical model of risk sharing. And given there is no storage, R star is a threshold. We prove in the paper that below some threshold there is no storage ever in equilibrium. So there is no storage, that's more or less it. What is important here to see, which is very intuitive, the thresholds are getting tighter as income is increasing. When you have a really good outside option, you don't have to hate that much to file for divorce, as simple as that, okay? So that's kind of, so smaller negative love shocks already trigger divorce for richer agents. So what is the next one? The next one is, now there is storage, no separations. So we play around no separations, but the love shock has no variance, it's always 0. And then you give the agent 0 who files for divorce. This is actually our case with Charlotte in the other paper. So given this, I'm going to be fast. Similar results for risk sharing. What is key here, that if there is high enough return, there is going to be savings. I told you, first best, you never want to use this household, never save anything. There is no need because it's a low return. You smooth consumption. Now what they are going to do, they are going to save. Why do they save? This is the Euler equation. And then I will explain more complicated ones. This one, they are going to be like this. But what is the intuition? Why do they want to save? Because 2 reasons. Binding participation constraints makes market endogenously incomplete. What does it mean in plain words? Consumption is going to vary over time, and precautionary savings comes in. Given consumption varies over time, it's useful to do some saving through fluctuations, even there is no aggregate uncertainty. 1. 2, if you save, you know that given that the one who files for divorce doesn't get any assets, you reduce the incentives for filing for divorce, and you can implement more risk sharing. So you save to improve future risk sharing and to smooth consumption now. Now let's take the other case, which is similar, storage, still no separations, gamma positive, say 1/2. I mean, I don't use 1/2, but that would make it simpler. So what is going to happen there? Of course, now default incentives are higher. If you want to divorce, you are going to get quite a lot of money if there are assets. So this is going to increase default incentives. Less risk sharing is implementable, but then how the household is going to respond? They are going to save less. How you can see it? You can prove it using this Euler equation. The Euler equation is the same. The same effect is there. This is the effect such that you would like to increase saving, to improve future sharing. So there is this positive effect, but it's going to be undone by this effect. Now, you increase the utility of ones who file for divorce, and this is going to be bad. This is bad for saving because you don't want people to divorce. You see, separations never happen, so you just reduce the sharing. There is no need to induce separation, so this is going to increase the outside options, and you can, and this is the analytical formula. The key here is that resharing is, asset accumulations are reduced. This is going to amplify the fact that resharing, because resharing is not there, asset accumulation is not there, resharing is further reduced. So in this environment, to go back to Albert's point, gamma equals 0 is clearly the best you can do. You cannot do anything else, just increase gamma. So now, we go back, now we allow for efficient separations, but how much? 5? But gamma is 0. So what does it mean? I'll go back to case who once files for divorce got nothing. But there are efficient separations. Now asset accumulations affects consumption after separation. And we have a beautiful equation, and for your sake I will try to explain this. Because you like this long expression. So, so what is going to happen now? I will explain the intuition. What is the intuition for asset accumulation? Of course, it's the same as usual for the range when tomorrow, for the range of combination of shocks but there is no divorce, is the same. You really would like to increase a bit of asset accumulation because it helps risk sharing. This is the first effect. The second effect is now there are divorce in the equilibrium path. So what does it happen? The one who is the innocent person, who didn't file for divorce, is going to receive all the assets. So now you can help to insure her along the path of divorce. It's going to be consumption smoothing effect through divorce. Is it going to be improving asset accumulation incentives? Yes, although it's not that easy to show fully analytically, but intuitively very much, because who is supposed to be the party who suffers? Typically the poorer. On average, they are going to be poorer, because when you want to file for divorce, when you have high Y, because the risk sharing is not that useful for you, and you have negative alpha, you don't have the love shock. So these people who are going to be left, they are going to have lower Y. They have lower Y. This is very useful to give them extra insurance by going to give them assets. So this is going to be, this part is exactly this. You are going to smooth consumption across divorce, but only those who are the innocent ones, not for the other guys. You don't see it from here, but you believe me. There is the last one, which is somehow the one, kind of the ones which, these ones I figured out a while before we started to work. This one, only after I didn't understand many times my equations, I figured out. So what happens then? Of course, the thresholds are going to change. How the thresholds are going to change? The more assets I have, the thresholds become wider. There is less divorce. Okay, that's easy to see. More assets you don't want to divorce because you are going to lose all these assets you don't want to divorce. But what is the effect of that? At the beginning I said, no, it should be good. Less divorce, more is sharing. But no, because you are going to go to the other side. In this world, you are going to make marriages inefficiently long. This number is negative. So you are going to make divorces less likely, but that at the margin is bad, because you keep people together who hate each other. That's kind of the very, very simple way to say it. So in this point, more asset accumulation is not necessarily good. It's good for this reason, but it makes marriages to stick together too long, because you are going to force, with more assets, you make people hate each other. Again, I cannot say it much better and much worse either. Okay, that's not important. So this I more or less explained everything. I have no time, no? Or 2 minutes? So.
It's efficient.
It's efficient, no? So what happens now when gamma is bigger than 0? Then I didn't even put the equation because the other equation didn't fit one slide. So, but if you followed somewhat until now, you can see what else is going to happen. Now, of course, in giving asset provisions for the partner who is filing for divorce, I already told you. This is bad in some sense. It's going to reduce risk sharing ex ante. Now he has higher incentives. He wants to file for divorce. So reduce risk sharing and increases divorce. That is, asset accumulation incentives are likely to be reduced. Okay. So everything is on this slide, so that's good. At the same time, it provides more consumption smoothing for those who file for divorce. This is important because I go a bit against what I said. Typically, lower income people are the ones who are going to be left in this model. But sometimes, even low income people are going to file for divorce. Why? Because this love shock can be really high. The love shock can be very high, and even when you're low income, you are going to file for divorce. So for these people, gamma positive is going to give some smoothing, and that might be variable. The second one, I talk about this inefficiency. You keep marriages too much together. So for example, when lambda equals 0.5, you can see it here. When lambda equals 0.5, these terms all cancel. So all these inefficiencies cancels by lambda bigger than 0. 1/2 is cancelled. So by continuity, by increasing lambda, you are going to reduce these inefficiencies like misallocation or mismatch. You keep together people who are not supposed to stay. The first best, they would be already separated. You will keep them together just because that helps you to have sharing, but this is kind of costly on this term of efficiency. So when you give asset provisions, positive ones, then you reduce this. So then again, obviously what is the conclusion of this? That we learn a lot from our model, but we have to get to the computer and calibrate it, because the overall answer, what is the optimal of gamma, is not obvious. It is not necessarily 0. We have now good arguments why it shouldn't be 0, but we don't know. It's somewhere in between. So that's just a quantitative question. So this is, let me just talk about this in the remaining 1 minute. So let's say, let me just summarize. Okay, this I said it. What you have to take away, probably, that in the presence of asset accumulation, there is trade-off between risk sharing within the match and consumption smoothing through marital statuses. That is something that is not going to be the same with gamma positive or not, or asset accumulation high or not. This is going to play around on this trade-off, which is not trivial and completely new compared to literature. The same with the inefficiency of marriages. So the probability division rules need to balance these effects, and then again, how? That's going to be quantitative. What do we want to do? I think this is the right order I change it. First, given that the answer, what we can get, seems to be quantitative in the more complicated setups of the model, we need to go, you complained about all this, we agree. For the quantitative ones, we need shock processes and outside options being more relevant. 2, what we thought about it, and then if you have ideas, because again, this is a good time to present because we will do at some point this. We work out quantitative applications, and we talk about 2 things for now. There was a change in the UK divorce law, which I don't remember. Charlotte knows much better than me. And we may want to use that one as a natural experiment and then to run it through our model. The second, there are cross-state legal differences, which Voena, in her AER paper in the 2015, uses cross-state differences in legal provisions of divorce. We may want to use this or something else. I mean, this is something which we can still. And then also, you talk about it. Extend the theory for proprietary division rules based upon other factors. Our model, this temporary Pareto weight, are going to be endogenous, and we can try to assume that also the division rule is going to depend on this Pareto weight. That's not that difficult. What is a bit more difficult is an empirical relevance somehow based upon income accumulated or the family, which it happens in some countries. That's not that easy because it creates a state variable, which is not an easy one. But we think about it. And then you talk about, one of you, I think, I don't remember who, about private Christian. I think there is this evidence that in a lot of couples, one of the partners is hiding assets under the carpet, preparing for the divorce. So this is something which, I don't know how empirical relevant, but this one we know a little bit how to do it already. So that these are the extensions. But probably we are going to do this first 2 at this point, and then we will start thinking about this one. That's kind of our plan.